Okay, we're in Unit 1 of Advanced Math, which was Fundamental Skills, so all this is a review. And Lesson 2 is going to be on factoring polynomials. I know y'all are so excited to revisit this topic. And we are going to cover a lot of material. I'm going to try to backtrack a lot. So remember, your goal in this section is to be locating things you're not good at. So if you find something you're not so good at, we need to really practice that a lot. Alright, when you factor polynomials, the first thing you do is you take out any greatest common factors if there is one. There's not always one. And finding the greatest common factor or pulling it out is like undistributing, because you should be able to distribute that greatest common factor back into your polynomial and get your original. Remember, we're not changing anything, we're not solving anything, we're just breaking it up. It's like going from 6 to 2 times 3. That's factoring. You didn't change the value, you just changed the format. Alright, let's look at example 1. We have the numbers 24y to the 4th minus 54y to the 3rd. Now when you factor out a greatest common factor, it's going to take the format of your greatest common factor times whatever you get when you pull that out. So first let's look at our two terms here. We need the number, what's the largest number that'll go into both of these? Now this is when knowing your facts will help you. You look at the two numbers, the largest number that'll go, and you can just start with the factors of 24. You know, run down that list, pick the largest one that will also go into 54. So I'm thinking 6 will go into both of those. Now, look at your variables. All of the common variables, remember this is your common factor. So what variables are common for each term? In this case, we only have the y. Now, you're going to pick the smallest exponent of y that you have, because this has to go into both of these. So if I pick y to the 4th, well, that won't go into y to the 3rd. But y to the 3rd will go into y to the 4th. So, y to the 3rd. Now, what are we going to have left over? Well, here's your sign. It's going to be negative. So we need to figure out what two numbers would go there. So, backtrack. I like to multiply better. So, you can divide both of these numbers by your greatest common factor. I find it easier just to say, what would I multiply 6y to the 3rd by to get 24y to the 4th? Well, that would be 4y. And then you can say, what would I multiply 6y to the 3rd by to get this back? Well, that would just be 9. So, this is your greatest common factor, and this is the whole term factored out. Okay, example 2, 51, a to the 8th, b to the 4th, plus 17, a to the 3rd, b to the 5th. And we want to factor out the greatest common factor. So, first of all, look at your coefficient. What's a number that will go into 51 and 17? Well, 17 is prime, so it's pretty easy. You know, you just have to ask yourself, will 17 go into 51? And yes, it will. So, 17 becomes the coefficient of our greatest common factor. Now, let's look at common variables. Both of these have an a and a b. So we're going to need one of each. Now we just need to pick the exponent. Remember, you're going to choose the lowest exponent that you have. I've got an 8 and a 3, so I'm going to choose the 3. On b's, I've got a 4 and a 5, so I'm going to choose the 4. Now, let's figure out what would be left. What would I multiply 17 by to get this back? Well, it would take 17 times 3 to get the 51. What would you multiply a times to get a to the 8th? Well, remember, when you multiply two bases, you add those exponents. So that's going to be a to the 5th. Now, b to the 4th already matches. So you just don't need anything. If you put a b here, then when you multiply it, you're going to get b to the 5th. And that's not what you want. Alright, whatever this sign is, goes here. Now, what would you multiply 17 by to get 17? Well, just 1. So you're not going to need to put anything. What would you multiply a to the 3rd by to get that back? Still 1. Now what would you multiply b by to get b to the 5th? just a b. So there's going to be your final answer on example 2. Okay, let's get into factoring past the greatest common factor. You always want to take that greatest common factor out. And then after you do that, your next step is to count your terms. Once you count your terms, that is going to tell you what method of factoring you need to use. So let's start with 2. If you count your terms and you have 2 left, you're going to have 3 options of factoring. Difference of squares, difference of cubes, sum of cubes. So let's look at them one at a time. A difference of squares has a formula or a rule, and it reads x squared minus y squared is equal to x plus y, x minus y. Now when you have a formula and you have a variable squared, your number in your actual problem doesn't have to have the 2. It doesn't have to have the exponent. It just has to be a perfect square. This just represents a perfect square. And since this is a perfect square, just the plain x represents its root. And it's really a lot easier for me to show you this. First of all, we're going to have to know, can we use it? So we need to know our perfect squares. What are your perfect squares? Well, there's 1 and 4 and 9, 16. You see how I'm getting all these. There's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared is 25, 6 squared is 36, 7, 49, 8 squared is 64, 81, 100, 121, on and on. You can go as far as you want to. So, let's just grab example 3. I've got 36w squared minus 25, and I want to factor it. So first I'm going to look for a greatest common factor, and there is not one. There's nothing that will go into 36 and 25. Now as far as your variables are concerned, any variable that has an even exponent is a perfect square. So 36 is up here and 25, we're good to go. Now what we're going to do is we're going to apply this rule. 36w squared compares to x squared. That's the first perfect square. So in my answer, my x is going to be the square root of that, which is 6w. Alright, then I'm going to have plus this y represents the square root of this. So what's the square root of 25? 5. Your other factor has the same numbers, just like that. Okay, let's look at example 2 now. Is there a greatest common factor between these two things? No, there is not. Alright, I have 2 terms, so do I have 2 perfect squares? Well, 1 is a perfect square and 144 is a perfect square. What's the square root of that? 12. When you look at these variables, remember, if a variable has an even exponent, then that is a perfect square, and its square root is the exponent divided by 2. So let's set this up. My first term is going to be the square root of this, which is 1 over 12, plus, alright, the square root of this, I'm going to divide r to the 6, I'm going to divide the 6 by 2, so I get r to the 3rd s squared. Now over here, it's going to be the same numbers, just opposite signs. Okay, let's look at example 5, 16x to the 4th plus 1. So how are we going to factor that? Okay, what do you think? Well, first let's look for a greatest common factor, and there's not anything that'll go into both. I know 1 will go into both of them, but you don't factor out of 1. You're not changing anything. Alright, next, do you have 2 perfect squares? Yes, you do. So, can you use this formula? No. No, you cannot. Why? Because the formula specifically works for a difference. What you have here is a sum. So what your answer actually is prime. You cannot factor this. This is simplest terms. I mean, it's like the number 5. You can't factor 5. So it's going to be prime. Let's look at example 6 now. 9a to the 4th b squared minus 100c squared. Do I have a greatest common factor? No, I do not. Do I have perfect squares? Well, 9 is a perfect square, 100 is a perfect square, And all of these variables have even exponents. So yes, I have two perfect squares, and do you have a difference? Yes, you do. So you can factor this as the square root of the first term. All right, the square root of 9 is 3. The square root of a to the fourth is a to the second. And the square root of b squared is just b. Now this first one we're going to put plus. It doesn't matter if you put plus minus or minus plus, but I'll just go with plus first. All right, what's the square root of 100? 10. And the square root of c squared is c. And then your second factor has the same numbers, but the opposite sign. Final answer. Okay, let's move into the next section, and this is going to be the sum and difference of two cubes. You still are at the point where after you took out a greatest common factor, if it existed, you counted your terms, you still have two terms. So you look at it and you don't have a difference of two squares, so check it and see if you have two perfect cubes. In order to know that, you're going to need to be familiar with your cubes. 1, 8, 27, 64, and you get a cube, the perfect cube, the same way you get a perfect square. Look at the number 2. If I cube 2, 2 times 2 is 4, times 2 is 8. That's why 8 is a perfect cube, and the cube root of it is 2. What's the cube root of 27? 3. What's the cube root of 64? 4. Cube root of 125 is 5. Okay, because you multiplied those by themselves 3 times. Now, here are your rules or your formulas. If you have the sum of two cubes, it works out like this, and we're going to work some examples. If you have a difference of two cubes, the only difference in these two formulas is signs. If you look at that, the numbers are the same. And you can remember the signs with SOAP. Your sign is same, opposite, always positive. What does that mean? Well, if you look at this, these two signs are, this sign is always the same as what you started with. This one is always the opposite of that. And these last two signs, they're always positive. Same thing here. These are the same. This is the opposite. This is always positive. So may help you out. All right, let's look at example 7. Analyze the problem. Take out a greatest common factor if you have one. There is not one. Count your terms. You have 2. Look at them and you can see that they're both perfect cubes. So we're going to use one of these two formulas. Since we have a plus, we're going to use the plus. Now, what I do on sum and difference of two cubes is this. I make a little chart over on my scratch paper of my root, the root squared, and the root cubed for both of these, just real quick. And you'll see how much easier that makes filling in your chart. So if I've got h to the third, what is the root? Well, it's h. The square of that is h squared, and then naturally the cube of it is h to the third. All right, on 125, what is the cube root of that? 5. That number squared is 25, and that number cubed is 125. So in your formula, everywhere you have a cube, that's going to refer to these two. Everywhere you have a square, that refers to these two numbers. And wherever you have just a plain x or y, that refers to the root. So we're going to use the top. All right, this x corresponds to the root of the cubed. So that's going to be h plus 5. Alright, now following my formula, next I need the square of the root of the first term, which was h squared. And then I need the two roots multiplied together. X times y means multiply these two cube roots together. So minus 5h plus the second term, the y term squared, 25. Okay? And that will be your final answer. Okay, let's have a look at example 8. 8 f to the third power plus 27. So analyze your problem. Do you have a greatest common factor? No, you do not. Count your terms, 2. So you're either going to use difference 2 squares or sum or difference of cubes. You recognize that you have 2 cubes and a sum, so that automatically tells you which formula you're going to need to use. Alright, now like I said, whenever I'm using sum or difference of 2 cubes, I just go ahead and make a list over here of my cube, the cube root, and the root squared. So the cube root of 8f to the third is 2f. This squared is 4f to the second. And that root cubed is 8f to the third. Alright, on 27, the cube root of 27 is 3. 3 squared is 9. 3 cubed is 27. Now these are all the numbers that I'm going to need to plug in to the formula. So we're going to use the top one. I need the root, the cube root of my given number plus the cube root of the second number. So that's going to be 2f and 3. So 2f plus 3. And you can look back here. This is the cube root of this. 3 is the cube root of 27. Now, x squared represents the root squared. So that's going to be 2f squared, which is 4f to the second, minus, now, cube root times cube root. So I can come back over here. 2f times 3 will get me 6f. Then my last number is the root of my second term squared, which is 9. Here's example 9. 27a to the third plus 512. So once again, there's no greatest common factor. I'm analyzing. I have 2 terms. They are perfect cubes. So I'm going to come over here. What's the cube root of 27? A cubed? Well, that's 3a. And what is this squared now? 9a squared. And what is this cubed? 27a cubed. So that's what I'm going to need for the rest of my formula. Now, what is the cube root of 512? 8. And what is this squared? 64. That cubed is 512. So these are the numbers I'm going to need to fill in. Alright, since this is a sum, I am using the top one. And I'm going to need the cube root of each term added together. So I can just look over here now. 3a plus 8 times. Alright, I need that root squared, which was 9a squared. According to my formula, I'm going to subtract. Alright, now for this middle term, I'm going to multiply the cube roots, the base roots of each thing. So 3a times 8 is 24a. And then this tells me to take the square of the root of the last term, which was 64. There you go. Okay, example 10, 729 m to the 6th plus 64 m to the 3rd. So, there's no greatest common factor. We do have 2 perfect cubes. How do I know that m to the 6th is a perfect cube? Well, if your exponent is a multiple, just like I told you, if it's a perfect square, you have an even exponent. That's because those are all multiples of 2. Well, when you're looking for a cube, if it has a multiple of 3, then that's a perfect cube. So, yes, we do have 2 perfect cubes. Now, let's make a chart. What is the cube root of 729? 9. And if you notice, I put the cube root on top of the numbers up here. That just makes it quicker. Alright, so what's the cube root of m to the 6th? Well, you divide this number by your root. So 6 divided by 3 is 2. So the cube root of 729 m to the 6th is 9m squared. Alright, now what is this squared? 81 m to the 4th. And then the cube of it is what we were given, m to the 6th. Alright, what is the cube root of 64? 4. And the cube root of n to the 3rd is just n. Let's square this. That gets 16n squared. And then the cube was 64 n to the 3rd. Alright, so now let's come over here. That was the hard part. Now we're just filling in. All right, I need the cube root of the first number, which is 9m to the second. And then the cube root of the second number, which was 4n. All right, according to my formula now, I need that root squared. So that's going to be the 81m to the fourth minus, okay, for this middle term, I'm multiplying the cube roots of both terms. So that's going to be 9m squared times 4n. So 36m squared n. And then plus the last term squared, or the root of the last term squared, 16n to the second. Okay. And that's it. So now let's look at example 11. And you notice I kind of combined all of the cubes, whereas your guided notes separated them. So all the first ones we worked were all sum of cubes. These are all going to be a difference of cubes. But the formula is exactly the same except for sign change. But it won't hurt us to practice these because I don't think you get a lot of practice in your other algebra classes. So anyway, look for greatest common factor. There's not one. Do you have two perfect cubes? And yes, I do. So what I'm going to do is make my little chart. What is the cube root of x to the third? Just x. What is this number squared? X squared. And what is the root cubed? All right, on 343, what's your cube root? 7. What is this root squared? 49. And then that cube was 343. So now we're going to be using the bottom formula since this is a difference. The only thing changed is going to be the signs. So I want my cube root of the first and second terms, x minus 7. All right, now I want the square of the first, so that's x squared. All right, for my middle term, I'm going to multiply the cube roots of both of these numbers. So that's going to be x times 7, which is 7x. Then my last thing is the square of the root of this, which was 49. Okay? Are you kind of getting the hang of it now? So here's example 12. We have 125 minus 8v cubed. There is no greatest common factor. We do have two terms, and we have a difference of perfect cubes. So here's the formula we're going to use. Now, once again, I'm going to take these two numbers, and I'm going to find the roots of each one, which is 5 and 2v. Then I'm going to find the square of each one, which is 25 and 4v to the second. And then the cube of each one, which is your given numbers. All right, now, so to correlate it to the formula, my first two numbers are the roots. So I've got 5 minus 2v. All right, next I need the square of the first term, or the square of the root of the first term, which was 25. Then I need the product of the cube roots of each term. So that's going to be plus 10v. And then the last one is the square of the root of the second. So plus 4v to the second. There you go. Okay, this is example 13. 1000m cubed minus 1. There is no greatest common factor. I do have two perfect cubes. This is a difference, so I'm going to use the second formula. Once again, I'm going to make my little chart over here. The cube root of 1000m to the third is 10m. This squared is 100m to the second, and the cube is 1000m cubed. Alright, the cube root of 1 is 1. That squared is 1. That cubed is 1. So that's just going to be 1. Alright, I'm using my bottom formula here. I want the cube root of the first number, which is 10m, minus the cube root of this, which is 1. Then I want my root squared, which was 100m squared, plus, alright, the cube roots multiplied times each other. 10m times 1 is just going to be 10m. and then the square of the second one. Okay? Easy peasy lemon squeezy. Okay, example 14, that's the last one on the first page of your guided notes. So there is no greatest common factor. I do have a difference of 2 cubes, so I am going to use this formula. So I'm going to take my first number, p cubed, and I'm going to write down the cube root, which is p, then that root squared, which is p squared, and then that root cubed, which is p cubed. Now, the cube root of 216 q to the third is 6q. This squared would be 36q squared, and then that cubed is what I have, 216q cubed. Alright, now let's fill it in. We're using the bottom formula, so I want the cube root of my first term minus the cube root of the second one. Okay, now I need my square of the first term, which is p squared, plus, alright, x times y correlates to the product of the cube roots of both. So that's going to be 6pq. And then the last thing is 36q squared. And that is all. Okay, so that wrapped up the first page of your guided notes. So flip over to the second page. Now you see the next topic is trinomials, but we're actually going to skip down and do your 4-term polynomials first, and then we're going to come back to trinomials, okay? So for 4 terms, your method is going to be factoring by grouping. And you would look at your problem, you take out any greatest common factor, if there is one, always. There's not one. So we count our terms. 1, 2, 3, 4. There's only one method to use, factoring by grouping. So let's see how to do that. Well, how do you group? What's a grouping symbol? Parentheses. So what you're going to do is group these 2 and 2. Just group the first 2 together and the second 2 together. And then you're going to factor out a greatest common factor from each group. So what's the greatest common factor between these 2? Well, nothing will go into 2 and 3. So we go to our variables. We do have an h in common in both of them. And what's the lowest exponent of h that we have? H squared. So that's my greatest common factor. Now, like I said, I like to do these backwards. I ask myself, what would I multiply h squared by to get my original back? 2h. You could say, if you divide 2h to the third by 2h squared, by h squared, you get this. Either way you want to look at it. Alright, what would I multiply h squared by to get this back? Just the 3. Okay. Now come down here. What's the greatest common factor between 6h and 9? That's going to be just the 3. So what would you multiply 3 by to get 6h back? 2h. And what would you multiply 3 by to get this? Minus 9. Now, if you notice, something very interesting happened here. When I factored out my greatest common factor, the other factor match. Okay? This has to happen at this point when you are factoring by grouping. If it doesn't, you need to go back and check because you probably made a mistake or your polynomial is prime. But in most cases, it's because you made a mistake. So don't just give up. Check it. All right, now we are going to factor again. What we have here, since these 2 things are multiplied together, these function as 2 terms now. So we want to pull out the greatest common factor. What is common in both of these is the 2h minus 3. So we're going to pull that out. And that becomes your first set of parentheses. Alright, now if I divide that out of here, what do I have left? Just the h squared. And if I divide it out of here, what do I have? The 3. Okay? And this is factored form. Let's do another one. Okay, this is number 22. And going through the analysis, do you have a greatest common factor? No, you do not. Count your terms. 1, 2, 3, 4. So we're going to factor by grouping. That's my only alternative. How do you start factoring by grouping? Well, first you group 2 and 2. Alright, now from each group, we're going to factor out the greatest common factor. The greatest common factor between these two terms is just z to the second power. So what do you have left over? What would I multiply z squared by to get z to the third? Just the z. What would I multiply z squared by to get 7z squared back? Just the 7. Alright, now this is the interesting part here. This time we have a minus, so we have to keep that in mind when we're factoring out. What's the greatest common factor between 5z and 35? 5. So now, what would I multiply 5 by to get this back? Z. Alright, now you got to pay attention because this 35 has a minus in front of it. Now if I redistribute this, if I remultiply, what would I multiply by to get negative 35? I would multiply it by positive 7. So anytime you're factoring out a negative number, it's going to change the sign here. Alright? And now, just like in the other problem, those two things match up. So that becomes your new greatest common factor. If I looked at this as these are now two terms, z plus 7 is my common factor. And what do I have left over? The z to the second, this sign, and 5. Okay, let's look at number 23. I look for a greatest common factor. There's not one. I count my terms. 1, 2, 3, 4. I know my only option is to factor by grouping. So let me go ahead and group 2 and 2. Alright, looking at the first group. What is the greatest common factor? Well, 3 will go into 6 and 9. Now look at your variables. They both have an r, and you want to take the lowest exponent of r that's present. So that's going to be squared. Alright, now, what would I multiply 3r squared by to get 6r cubed back? 2r. What would I multiply 3r squared by to get 9r squared? Just by 3. Alright, now down here, 10r and 15. What goes into both of those? 5 does. What would I multiply 5 by to get 10r back? 2r. What would I multiply 5 by to get 15? 3. And once again, you see the magic happened, and I came up with matching sets of parentheses. So the matching set of parentheses is going to become my first factor, and these two numbers will make up my second factor. Okay, this is number 24. So first I'm going to look for a greatest common factor all the way down, and there's nothing. So I'm going to count my terms. 1, 2, 3, 4. I know my only option is to factor by grouping. So let me go ahead and group 2 and 2. Alright, take your first set, factor out any greatest common factor. Well, I know 4 will go into both numbers. They both have a c, and I'm going to take the lowest exponent of c that's present. So now, what would I multiply 4c squared by to get 4c cubed back? Just a c. What would I multiply 4c squared by to get 20c squared back? Just a 5. Okay. Alright, now down here, what's in common for both of these? Well, a 9. So when I factor a 9 out of 9c, I just have the c. What would you multiply by to get 45? 5. And you see, once again, those parentheses match. So that becomes one of your factors. And 4c squared plus 9 is your other. And it doesn't matter whether you put the 4c squared plus 9 first or second. Remember, multiplication is commutative. So either way. Okay, now we're going to back up and do trinomials. Okay, let's back up to the trinomial section now. And we're going to look at trinomials as if they are two different things. We're going to have a trinomial that we call a is equal to 1 and a trinomial that we call a is not equal to 1. If you remember, standard form of a quadratic, the coefficient of your x squared term, that's your a. So what I'm talking about when I say a is equal to 1 is going to be a trinomial that looks like this. Your squared term, your quadratic term, has a coefficient of 1. For example, this one, your quadratic term has a coefficient of 3. So this would be an a is equal to 1 trinomial. This would be an a is not equal to 1. So first let's look at trinomials where there is a coefficient of 1 in front of your first term. So before we get into factoring those trinomials, let's back up just a second. I want to FOIL this real quick because factoring and FOILing are opposite operations. And if you know where those terms came from, it's a little bit easier to break them back down. So what would I get if I multiplied this together? Well, I would have x squared plus 3x plus 2x plus 6. And then your middle terms would add together. So you see how a trinomial comes from two binomials that were multiplied together. So if I have a trinomial and I'm trying to factor it, I'm looking for those two binomials that it came from. And notice some of the relationships here. This first number was achieved by multiplying these two first things together. This last term was equal to the two last numbers multiplied together. And the middle term, you can add those two numbers together to get it. So there is a relationship between the multiplication of two binomials and the resulting trinomial. And we're going to use that information to make it easier to factor one. Okay, so let's look at this example. Now we know that if we have a trinomial, it came from multiplying two binomials together, and I want to find out what those are. So let's work backwards. Where did this come from? Well, it came from multiplying those two things together. So that's going to be m and m. All right, now let's think about our sign. If I got this number from multiplying these two together, and this is negative, what do I know about those two signs? Well, I must have one positive and one negative, because that's the only way to get a negative number. All right. Now, it gets a little bit tricky for these two numbers, because if you'll remember, they have to multiply to give us 30, but they have to add up to give us 13. And I know this one is easy to see, but I'm just going to show you what the process would be. Take the last number and make a little tree under it, and we're going to put all the numbers that multiply to give us that. And since it's negative, I have one of each pair. If it were positive, I wouldn't need one of each pair. Negative 3, positive 10, 3, negative 10. Okay, so which of these pairs adds up to give you the negative 13? That one right there, positive 2 and negative 15. So we'll just put. Okay, let's move on to number 16 now. Before we do that, here's a chart for your signs, and you may want to jot this down on your guided notes sheet somewhere. If your trinomial has two plus signs, then your factors are going to have two plus signs. If your trinomial has a minus and a plus sign, then you're going to have two minuses in your binomials. In other words, if your second sign is a plus sign, your signs are going to be the same, and they're going to be whatever the first sign is. Now, if your second sign is a minus sign, you're going to have one of each sign, and it doesn't matter which position you put them in. Okay, so let's look at this one. Now, when I factor this, it is a 1 coefficient here, so I'm using this method. Let's go ahead and say we're going to need an A and an A. Now, according to my chart, what sign do I need? Since this is minus, I'm going to have one of each, and it really doesn't matter right now where you put each one. That will fall into place. All right. Now, for my second numbers, I'm going to put a chart under the 80, and I'm going to make a list of the factors of 80, and I'm looking for a pair that I can add to get 11. So they multiply to give me negative 80, but they add up to give me positive 11. So let's see. Negative 180, 1 negative 80, negative 240, 2 negative 40, 3 won't go, negative 420, 4 negative 20, negative 5 16, 5, negative 16, and here's a winner. Once you find it, you don't have to go any further. Negative 5, 16. So the negative 5 is going to go where the minus is, 16 goes where the plus is, and you're done. And this is number 17, x to the 4th minus x squared minus 20. So we can go ahead and set up our two binomials over here. Since we have a coefficient of 1, we know this is an a equals 1 problem. All right, what is the square root of x to the 4th? X squared. All right, since this is a minus sign, you're going to have one of each sign. And now I need a pair of numbers that multiply to give me negative 20, but add up to give me, what's the coefficient of this middle term? It's understood to be 1. So, negative 1 times 20, 1 times negative 20, negative 2 times 10, 2 times negative 10, 3 won't go. Negative 4 times 5, or 4 times negative 5. So there's your winner right there, 4 and negative 5. So the 5 is going to go where the minus goes, and the 4 goes right there. Okay, let's wrap it up now. We're going to look at the other kind of trinomial. And by the other kind, I mean where you have a coefficient in front of your quadratic term. So this is the one that is the a not equal to 1. And the method I'm going to show you is the AC method. There are other methods. There's trial and error, there's slip and slide, there's multiple ones. This is the one that just makes the most sense to me. So what is the AC method? You start off by multiplying a times c. What's a and c? Well, remember, when you have a quadratic expression, the coefficient of your first term is a, and your constant term is c. So when I say multiply AC, I'm going to multiply 2 times negative 7 and get negative 14. Now, this is fixing to look a whole lot like the method we just used, but there's going to be a big change. So just hang on, stay with me. I'm going to make a chart under the negative 14, and I want all the numbers that add up, that multiply to give me negative 14. And I'm going to pick the pair that adds up to give me my middle term, which is this one. And now that's where it stops being like the other method. Because what I'm fixing to do is I'm fixing to create a 4-term polynomial. You know, we learned how to solve those. You do it by grouping. So if I can get a 4-term polynomial, then I've got something I can work with. Now, instead of writing 13, negative 13, I'm going to split that up, and I'm going to put plus 1d minus 14d. Isn't that the same thing as negative 13d? And then I will have my 2d squared here and my minus 7. Okay, so all I did is split that up. Now, how did I split it up? Well, I was very careful to pick some numbers that are going to help me out. Now that you have a 4-term polynomial, we are going to factor by grouping. Greatest common factor here is d. So I have 2d plus 1. Here's your minus sign, so be careful. What's the greatest common factor here? 7. So I have 2d. And remember, since you're factoring out a negative, it changes that sign. Now, remember this? The magic happened. We wound up with 2d plus 1 for our first set and d minus 7 for the second set. Okay, well, let's work another one. Okay, here's number 19. So we have this trinomial. We look for a greatest common factor, and there's not one. We count our terms, 1, 2, 3. We know that we have a trinomial. So we look to see, can we use the easy method, or do we have to use the AC method? Well, since it has a coefficient, we must use the AC method. And let the name of the method kind of lead you into it. AC means you're going to multiply A times C. So I'm going to start with 90, and I'm going to make a chart. Now, since it's not negative, I don't have to do positives, negatives. I'm going to make a chart with all the factors of 90 and 5 and 18 until I find a pair that add up to give me 21. All right. And it's not that these are both positive, it's just that they both have the same sign. So no matter what, you're going to be adding them. All right, I'm going to split the 21. And since 21's negative, they are both going to be negative. But when you multiply two negatives together, you do get the positive. But when you add two negatives, you get the negative. So I'm going to rewrite this as 10g to the second minus 6g minus 15g plus 9. I'm ready to group. I'm going to group the first two and the last two. And I'm going to take the greatest common factor out. Now the greatest common factor between these two numbers is going to be 2g. So I'm going to be left with 5g minus 3. The greatest common factor here is going to be 3. And I'm factoring out a negative number, so it's going to change that sign. So this will be 5g minus 3. Once again, the magic happened. Those two match, so they become my greatest common factor. Okay? Now I have 2g minus 3 left over. And you can foil that back together. Make sure you get your original, and that way you'll know you're correct. Okay, number 20. So, see a trinomial, there's not a greatest common factor. I have a coefficient in front of my first term, so I'm going to use the AC method. Alright, I'm going to multiply A times C. 16 times 25 gives me 400. Now, I need a pair of numbers that will multiply to give me 400, but add up to give me 40. Now, sometimes you just have to power your way through it and make the whole chart, but you know, it was pretty quick, or it came to me pretty quickly that, hey, 20 times 20 equals 400, and 20 plus 20 equals 40. So, I got lucky. I thought of it right off the bat. So, let's go ahead and come over here. I've got 16w to the 4. I'm going to have plus 20w squared plus 20w squared plus 25. Alright, now I am ready to factor by grouping. So I'm going to group and I'm going to group. Greatest common factor here is going to be 4w to the second power. So when I divide it out of here, I got 4w to the second plus 5. Alright, greatest common factor here is going to be 5. When I divide it out, I'm going to get 4w to the second power plus 5. And yes, once again, I wound up with matching factors. So that becomes my greatest common factor for this step. I've got both of those out of there. What's left? Oops, that should be a w, sorry. And 4w squared plus 5. Which you could rewrite as simplified 4w squared plus 5 squared. Okay, in the bottom section, we're just told to factor completely. No specific method. We have to do the analysis now and figure out how to factor that. And this is more along the lines of what you're actually going to be doing, because factoring is just a part of a bigger problem. So when we get ready to factor, we always look for a greatest common factor. And 5n will go into both of these. So what do I have left over when I take 5n out of this? Into the 4. How many times will 5 go into 180? 36. And I've already got an n, so I don't need that. Alright? Now, I look at my term here. How many terms do I have? 2. And so the only options I have is, can I factor with a difference of 2 squares or a sum or difference of cubes? Well, I do have 2 perfect squares here. So let's use that formula. If you remember, it's the square root of the first. So the square root of n to the 4th is n to the 2nd plus the square root of this times the square root of this minus. Okay? And then you always want to check your factors and make sure you can't factor more. But this is complete right here. Let's go to the next one. Okay, number 26. I do have a trinomial, so let's look for a greatest common factor first. Now, all of these are even, so I could take out a 2. Let me give you a tip here. Since my leading coefficient is negative, that's not good. But we can factor that out as well. The greatest common factor between all of these things is 2. But if I go ahead and factor out a negative number, that's going to change all these signs and it will make this positive. So when I factor a negative 2 out of 6, I get 3k squared left. When I factor negative 2 out of this, I get positive 7k, which that's not important. I mean, it's going to be nice, but the main thing is to get the negative away from your leading term. And then negative 2 into negative 4 would give me positive 2. Okay, and you can check it. If you redistribute that negative 2 times all 3 of these, you'll get your original. All right? Now, we look at just this part. We have a trinomial. We do have a coefficient in front of the first term, so that means we're going to have to use the AC method. So I'm going to multiply A times C. 3 times 2 is 6. And I'm looking for a pair of numbers that will multiply to give me 6, but add up to give me 7. And right there it's 1 and 6. Now I don't want to forget my negative 2, because when you factor, you don't want to lose any of the value. So it's factored out, but it's still going to be a part of my answer. Now, when I do the AC method, my first term doesn't change. I am rewriting my middle term to be the sum of 2 other ones. And I'll put 1k, you could just put the k. 6k plus 2. Now I have 4 terms, so I'm going to factor by grouping. And like I said, I'm not going to lose my negative 2, so I'm going to write it down. Now, what is the greatest common factor between 3k and 1k? And I'll put brackets here because I'm factoring this. Well, I'm going to take a k out, so that's going to give me 3k plus 1. Now down here, your greatest common factor between 6k and 2 is 2. When you factor 2 out of here, you get 3k plus 1. Okay? Once again, I'm not losing my negative 2. Now, this becomes your factor. So you have 3k plus 1. And these two numbers make up the other factor. So there you go. Okay, let's look at problem 27. We have a trinomial, and the first thing we always want to do is look for a greatest common factor. Now we do have a k all the way down, so let's divide it out, factor it out. And what's that going to leave us? J to the 4th plus 3j to the 2nd minus 28. Now, looking at this trinomial, I do not have a coefficient in front of my first term, so I don't have to use the AC method. I can use the unfoiling or the easy method. Now, I don't want to forget my k, so I'm going to keep bringing it down. Now, when you factor this trinomial, if you remember, you're going to get a binomial. Since there's no coefficient here, I just need the square root of this number. So that's going to be j to the 2nd, j to the 2nd. As far as my signs go, since this is a minus, I'm going to have 1 plus and 1 minus. Now, I need a pair of numbers that will multiply to give me negative 28, but will add up to give me positive 3. So since this is negative, I would have negative 7, positive 4, or positive 7, negative 4. You can make a whole chart if you want to, but if the correct one just jumps up at you, go ahead and grab it. I need positive 3, so it's going to be the positive 7, and the 4 goes here. Okay? Now that's factored, but hang on, because you always need to check your factors and see if you can factor any more. One of the most common ones is this situation right here. This is still a difference of 2 squares. So I can factor it even more. Now the k, I don't want to lose it. J squared plus 7 is a sum. It's not perfect squares, it's not cubes, so I can't do anything with that. This I can factor into j plus 2, j minus 2. So don't neglect that. A lot of people get caught because they don't go ahead and factor that last thing. Okay, let's move on. Problem number 28. I see that I have 4 terms and I do not have a greatest common factor all the way through. So let's go ahead and start. How do you factor a 4-term polynomial? You can only factor by grouping. So I'm going to group here and here. And then I'm going to factor the greatest common factor out of each set. Now the greatest common factor between these two numbers is 3s to the second power. So when I divide that out of here, I get 5s plus 2. Alright, down here, my greatest common factor is 2. When I divide it out of there, I'm going to be left with 5s plus 2. And the factor by grouping magic happened. There's my common factor. So that's going to be 5s plus 2. And then what's left over is 3s to the second plus 2. I checked both of them. Neither one can be factored. So that's your final answer. Okay, let's look at number 29. We do have a trinomial. We have a coefficient in front of the first term. Always look for a greatest common factor, and there's not one. So we are going to have to go with the AC method. So multiply a times c, 4 times 9 is 36. Now what I want to do is I'm going to recreate a 4-term polynomial. So I'm trying to split the negative 13q squared. Now the 4q to the 4th power is not going to change. What will multiply to give me positive 36 but add up to give me negative 13? Well, if both numbers are negative, they will multiply to give me positive and add up to give me negative. So we've got negative 1, negative 36, negative 2, negative 18, negative 3, negative 12, negative 4, negative 9. And there's a winner right there, negative 4 plus negative 9. So, since this is a q squared, I'm going to put minus 4q to the second minus 9q to the second plus 9. And look at it carefully. All I did is rewrite 13q squared as negative 4q squared minus 9q squared. Okay. To factor by grouping now, that's the next step in the AC method. So what's the greatest common factor here? Well, 4q to the second is going to be my common factor. And when I divide it out here, what do I have left? Q to the second minus 1. Minus down here, what's my greatest common factor here? 9. Now I'm factoring out a negative 9, so what's going to happen? The q to the second, this positive, is going to change to a negative. So now, these two things match. They become my first factor, q squared minus 1. And then this 4q to the second minus 9 becomes my second factor. Alright, now this is one of those you got to be careful on, because you still have a difference of 2 squares in both of these sets. So let's factor them down. Q to the second minus 1 will factor into q plus 1, q minus 1. 4 squared minus 9 will factor into 2q minus 3, 2q plus 3. Okay? Now, checking again, everything looks good, so this is final form. Okay, let's look at problem number 30. 6z to the 4th minus 30z squared plus 24. We always want to look for that greatest common factor, and 6 will go into all of these. So let's take the 6 out first. And that's going to leave us with z to the 4th minus 5z to the second plus 4. Now we need to factor this trinomial. We do not have a coefficient, so we're just going to factor it into 2 binomials. The first terms will be the square root of that, so z squared both places. Now, what about your signs? If your second sign's a plus sign, your signs are going to be the same, and they're going to be whatever this is. So we're going to have minus and minus. Now, I need a pair of numbers that will add up to give me, multiply to give me 4, but add up to give me 5. So how about 1 and 4? Now look at my factors, and once again, I have difference of 2 squares in both of these. So we need to keep factoring. Don't lose that 6. Z squared minus 1 factors into z plus 1, z minus 1. Z squared minus 4 factors into z plus 2, z minus 2. Okay? And there's your final factored form. Okay, let's knock out number 31. 9y to the 6th minus 576. A greatest common factor here is 9. So when I take 9 out, I'm going to have y to the 6th minus 64. Now if you look at this, you actually have a difference of 2 squares and you have a difference of 2 cubes. If you have an option like that, go with the difference of 2 squares. So 9, the square root of that is going to be y to the 3rd minus 8. Now remember, when you're taking the square root of something with an exponent, you divide that exponent by whatever root you're looking for. Since we're looking for the square root, that's 2, so I'm dividing the 6 by 2. That's why I get a 3. Alright, so I just applied the difference of 2 squares. Y cubed minus 8, y cubed plus 8. Now my factors, I have one difference of cubes and one sum of cubes. So I'm going to be using these formulas. Now I don't want to forget my 9. Alright, first I'm using the difference. So I want the cube root minus the cube root. And then I want this squared plus these two multiplied by each other plus this squared. Alright, now I've got to factor this the same way. This is going to be a sum. So I'm going to take the cube root of this plus the cube root of that. And then I want my first term squared. So that's y squared minus 2 times y plus 4. Okay? That was pretty intense, but there you go. Okay, last one, number 32. Let's knock this one out. Negative 15 a to the 3rd b squared plus 60 a b to the 4th. First thing we want to do is take out a greatest common factor if there is one. And since my leading coefficient is negative, when I factor that out, I'm going to factor out a negative so I don't have a leading negative. Alright, what will go into 15 and into 60? Well, 15 will. So I'm going to factor out a negative 15. Now, let's look at our variables. We have a's and b's in both of them. Now let's go through and take the smallest exponent of each. The smallest exponent of a that I have is this a right here. So I'm going to leave that. Now b, I have a b squared and a b to the 4th. So my smallest one is that b squared. Alright. Now what would I multiply negative 15 ab squared by to get this back? Well, that's going to be a squared. Alright, now since I'm factoring out a negative, it's going to change that sign. Now how many times will 15 go into 60? 4. And then ab squared, we'll already have an a, but I'm going to need a b squared. Okay, now look at this one. That will factor again. So I'm going to bring that down. This is actually a difference of 2 squares, and it will factor into a plus 2b, a minus 2b. And that is all.